In the last video, we talked about combining like terms. And we needed to combine like terms before we could solve multi-step equations. Now that we have combining like terms in our toolbox, we can move on. Remember, an equation is two mathematical expressions with an equal sign in the middle. It might look like 3x plus 1 equals 4x minus 6. Our goal when we solve equations is to isolate the variable. That will give us the one number, or allow us to solve anyway, for the one number in the entire universe that makes that equation true. When we solved single variable equations, or single step equations, we were able to jump right in. The problem now is before we isolate the variable, we have to look for some things. The first thing we are going to do is we are going to check for like terms. We are going to see if there's anything that we can put together on either side of the equation. We are also going to check for an opportunity to use the distributive property. Those are two things that we need to take care of before we can solve for the variable. Once we've done those, we can solve. Now there's no time like the present, so we are going to jump right in. One of the things that I know some people struggle with is the idea of if you do it to one side, you do it to the other. And so one of the things that has frequently helped my students is to draw a line down through the equal sign. That helps them visualize that there are two sides to the equation. We've got the left side and the right side. And it helps them remember that if we do something to one side, we have to do it to the other. Now, because I was listening to myself a minute ago, I know that the first thing I need to do is check for like terms. So if I look at the left side of my equation, I see that I have a 4n minus 2n. Now those fit my requirements for like terms, so before I do anything else, I'm going to combine those. (4n minus 2n) is a positive 2n, and I'm going to bring down my 4. On the right side of my equation, all I have is that lonely 4. There are no other constants behind it. So I don't have any like terms I need to combine there. The other thing to look for was the distributive property. So we were looking for something that might look like this, that we needed to simplify before we could solve for the variable, but I don't see anything like that in our equation. So that means we can continue solving. We're still using the idea of opposite or inverse operations. My 2 is multiplied by the n. The opposite operation, or the inverse operation for multiply, is divide. So I need to divide by the same number on both sides of the equation. Well, I know that 2 divided by 2 is 1. 4 divided by 2 is 2. Now, math people are lazy. If it's 1 times a variable, we don't write the 1. So this is n equals 2. If I wanted to check it, if I wanted to see if I had the right answer before I turned in my paper, I can totally do that simply by plugging the 2 into my original equation and checking to see if I get 4 as the result. So if I plug in the 2 for the ends, I would have 8 minus 4. And the last time I checked, 8 minus 4 was 4, which is absolutely always going to be equal to 4. We'll do one that's a little bit better. I'm going to continue drawing my wall. This side, or this time, my equation is flipped a little bit. This time I have the simpler side on the left, the more complicated side on the right. That's not a big deal. We're still going to use exactly the same skills we used before to conquer this guy. I'm going to check for like terms first. The negative 12 is all by himself. There are no more terms over there, so I don't have to worry about him. When I look at the right side, I notice that I have a positive 5v and a positive 2v. That means the right side of my equation is going to become 2 plus 7v. And on the left, I'm just going to bring down my 12 because I don't have anybody to combine him with. Next, I need to try to isolate the variable. Before, when we did one-step equations, all we had to do was multiply, divide, add, or subtract, and we were done. But here's the thing. Now we have 2 operations on this side of the equation. We have multiply and add, and we have to undo both of those in order to solve the equation. So a long time ago, another teacher and I were talking about this, and this is how we approached it. I said, let's pretend that you are the variable. Your parents go out of town. You decide to throw a party. The one that shows up first, the one that is the closest to you, is your best friend. That is your BFF. These guys out here are people that your BFF invited. Now, when your parents come home early, who are you going to kick out first? Your BFF or the people your BFF invited? I don't know about you, but I would totally kick out those extra people first. So, to do that, we need the opposite operation. There's an invisible plus in front of that 2. That means it's positive 2 plus 7v. The opposite of positive is negative. So I'm going to subtract 2 on both sides of that equation. That is going to cancel out my 2's on the right. I'm going to be left with just 7v on the right. Negative 12 minus 2 is a negative 14 on the left. Now it's just you and your BFF. Your parents are now going to send your BFF home. The opposite or the inverse operation for multiply is divide. So we divide both sides by the same thing. That means that v is negative 2. If you want to check it, similar process as the other one. We check to see if negative 12 is equal to 2 plus 5 times what we got, plus 2 times what we got. So this would be 5 times negative 2 and 2 times negative 2. This would be 2 minus 10 minus 4. 2 minus 10 is negative 8. Minus 4 is negative 12. And the last time I checked, negative 12 was absolutely equal to negative 12. let's look at one that might be a little different. Let's take a look at this one. Now, there were two things we checked for. First, we checked for like terms. On the left, all I have is a 6. I don't see any other constants, so there are no like terms there. On the right, I only have one chunk of stuff I have to deal with. I don't see anything else that looks like that either. Now, the second thing we had to check for was the distributive property. And we have a textbook example of the distributive property right here. So before we can jump in and solve, we need to expand the right side of our equation. So to do that, I'm going to do -3 times x and -3 times 2. I'm going to simplify a little bit. So I'm left with -3x minus 6. So once again, you are the variable. The -3 is your BFF. The -6 is the friends of your BFF. If you throw a party and your parents come home early, you are going to kick out your BFF's friends first. So when we add 6 to both sides, because adding is the inverse of subtracting, we get 12 is equal to -3x. And unfortunately, now it's time to kick out your BFF. The two of you are multiplied together, so your parents are going to divide you. -3 divided by 3, or -3, gives you a 1, so you could say they cancel each other out. And x is equal to -4. If you wanted to check it, you could absolutely plug it back in the original to see if you get a true equation. This one has a negative on the outside, and I want to make sure that you have an example of that one. I'm going to start by putting my line down the middle. A quick glance at both sides tells me I don't have any like terms, but I do have a representation of the distributive property. So I'm going to do -3 times 4r and -3 times -8. If I simplify the left side, I get -12r plus 24. My -36 stays the same. Again, we've got you and your BFF and your BFF's friends. We're going to kick out the BFF's friends first. They added themselves to your party, so to make them go away, we subtract them. And we have to do it on both sides, so we maintain the inequality or the equality of our equation. So I have -12r. On the right side, we get -60. If you need your calculator, absolutely plug that in the calculator. Don't risk missing a problem because you can't add and subtract correctly. Now it's time to divide you and your BFF. Our 12s will cancel out. And 5 is our R value. Now let's look at some that have parts to deal with on both sides of the equal sign. Let's take a look. Let's start small. And we'll look at 11. I'm going to put in my wall. A quick look at both sides tells me neither side has like terms for me to combine, but I once again have the distributive property. So I'm going to distribute my 3. I'll have a negative 3 times 1 and negative 3 times 6r. There's nothing for me to do on the right, so I'm going to bring it down just like it is. Now on the left, I get a negative 3 minus 18r. Now this is a little different. My BFF story doesn't work quite as well because I have an R and an R on both sides. So what we're going to do is we're going to pick a side to make the R's land on. I'm going to pick the right side. I want my R to end up over there. That means I need to take these 18 R's, the negative 18 R's, and get them over here with these guys. But I can't just erase them and write them on the other side. That doesn't work. Excuse me. I can only move things using inverse operations. So if I want to move a negative 18R, I need to add 18R. And I can only do it in one place on each side of the equation. When I do that, negative 18R plus 18R is 0, so those are going to cancel out. I have a negative 3 on the left, and 14 plus 18R minus 1R gives me 17R. Now, I want to move the 14 to be on the other side with the negative 3. But again, I can't just erase it and write it over there. I'm still focused on inverse operations. So if this is a positive 14, the inverse operation means I need a negative 14. Well, negative 3 minus 14 is negative 17. The positive 14 and the negative 14 cancel each other out. And I'm left with a 17R on the right. This is 17 times R. So to undo the multiplying, I need to divide. The 17s cancel each other out. And I'm left with R is negative 1. Let's do 15. We'll go big or go home. 15 has a whole bunch of stuff in it, but we are going to start with our list, where the first thing we check for is combining like terms. I am going to put in my line in the middle so that it is super obvious where each side of my equation lies. And I'm going to start over here on the left. I have a 10p and a negative p. Remember, if there's not a number or a constant or a coefficient in front of a variable, it's really a 1, and we were just too lazy to write it there. So I need to combine those two terms. I would have 10p minus 1p. That leaves me with 9 p's. Then I have a positive 9. It is just a constant. And a negative 11. That is also a constant. When I have two constants, I can combine those. So 9 minus 11 is a negative 2. On the right side of my equation, I can't combine like terms, but I can distribute. So if I do negative 2 times 2p and negative 2 times 4, but I have another one. I have more than one distributive property, and that's okay. I get negative 6p, and then negative 3 times negative 2. Then I'm going to clean that up a little bit. The left side is going to stay 9p minus 2. The right side, my negative 2 times 2 is a negative 4p. Negative 2 times 4 is negative 8. I have my negative 6p still. Negative 3 times negative 2 is a positive 6. I have some things I need to clean up on my right side still. I have a negative 4p and a negative 6p. Well, negative 4 minus 6 gives me a negative 10p. Then I have a negative 8 and a positive 6. That gives me, when I combine them, a negative 2. So we've done all of the combining on the left, all of the combining on the right. Now we are ready to solve. I need all of my p's on one side, all of my constants on the other. This time I am going to pick the left for my p's. So I want to move my negative 10 p's to the other side. Since they're negative, the inverse would be to add them. So I'm going to add 10p to both sides. 9 plus 10 gives me 19p. I didn't mess with the negative 2 yet, so I'm going to bring it down. And then I'm going to bring down this negative 2. Now I'm ready to move this negative 2 to the right side. It's subtracted, so I am going to add it. Negative 2 plus 2 is 0. Hang on. I got a little too excited. So I still need my 19p because the only thing that happened was that the 2's canceled out on both sides. Now this is 19 times p. So I'm going to divide by 19 on both sides. That means that p is equal to 0, which is a little bit disappointing because you would hope that after all of that work, you get something a little more exciting than 0, but alas, 0 is all we've got to work with. We will take a look at one more. Let's take a look at 20. I'm going to go ahead and draw my line. I'm going to check for like terms or distributing on the left side. I don't see any like terms, but I absolutely see a distribution opportunity. So I'm going to bring down my negative 11. Then I'm going to multiply 10 times p and get 10p. And then 10 times 10 is 100. On the right side, again, I don't have any like terms right off the bat, but I do see the distributive property staring at me. So I'm going to bring down the 4. And I'm going to do negative 5 times positive 2. That gives me a negative 10p. Then negative 5 times positive 11 is a negative 55. Now I'm going to do like terms on either side. On the left, I have a negative 11 and a plus 100. That gives me 89 plus 10p. On the right, I have a positive 4 and a negative 55. That gives me a negative 51 minus 10p. Now this is interesting. Right now, the tendency of a lot of people is to say, oh, look, I have a positive 10p and a negative 10p. That makes a 0. Please do not do that. The only way we can combine the positive 10p and the negative 10p is by using inverse operations. So if I want to move this negative 10p, I have to add it. So I actually end up with a 20p. They definitely do not cancel each other out, except for on the right side. Now I need the p by itself. So I'm going to subtract 89. And I'm going to do it on both sides because if I do it on one, I do have to do it on the other. Otherwise, I will not maintain my equality status. 89 minus 89 is 0. I still have the positive 20p. Negative 51 and negative 89 is negative 140. I divide by 20. I get that p is negative 7. And it is totally fine for you to get a negative number for your variable. If you wanted to go check it, you could plug it in for p in both places to double check your work. That is the end of solving multi-step equations. If you have more questions or you need some extra help, feel free to shoot me an email.